in the microscope, you see it go all silvery and metallic looking, and it looks a bit like mercury, and you can see it kind of ooze out a little bit, and it's turned into this metallic form of silicon. So I'm super interested in how we take this one form of crystal and we turn it into a whole different type of crystal.
Oh my God. Oh my God. I could talk to you for hours. So you make diamonds, better diamonds.
Yeah.
What other, because you also mentioned that diamonds is just one of the material or one of the element that you're interested in. What else do you squish and make pretty things out of?
So silicon, of course, drives our phones, drives our computers, drives our cars, basically, all of the silicon chips that we have. Also really important for energy applications. So solar cells, they're all made out of silicon. It's all made out of one structure of silicon.
Oh.
So it's all the same type of silicon, and it's the same type of silicon crystal.
Huh?
And actually, just interesting fun fact, it has the same crystal structure as diamonds, like shiny regular diamonds. So your diamond ring and your phone silicon chip have got the same internal structure. It's called a diamond cubic structure, and it's basically one of the simplest structures that you can get. It's all sort of cubic in terms of its arrangement. So I'm super interested in how we take this one form of crystal and we turn it into a whole different type of crystal. So we take the same elements and we just rearrange them. And we know if we rearrange carbon, we can go from graphite to diamond, super different. All we've done is rearrange the crystal structure.
Right.
The same with silicon. We can go from the diamond cubic structure and we can rearrange and form actually 13 different types of structures of silicon.
And what do these structures offer us? Like, can we make our phones faster?
Yes. Well, can we make our phones faster? Probably not.
Okay. What else can we do?
I think we could possibly make solar cells more efficient.
Oh, that's even better.
Yeah. So it has energy applications.
Oh, wow.
At the moment, when we use regular kind of this boring type of silicon that everyone else uses, the diamond cubic, I know, just so over it. When we use that form of silicon, we lose a whole lot of the solar spectrum. So we're not absorbing all the light that's coming down or all the energy that's coming down from the sun. We're only absorbing a very small, well, not a very small part, but one part of the spectrum.
Limited part, yeah.
Exactly. So if we had a form of silicon that absorbed more, then we would have a more efficient solar cell. Now, the catch with all this is you need to make these new crystals, you have to make them at high pressures. And that is sort of a relatively complex and expensive process. So one of the real challenges in this area is how to create an industrially scalable amount of these materials. Because when I do all of my work, most of it is done in these tiny little devices. Well, they fit in the palm of my hand, about this sort of the palm of my hand sized. And the samples I load into these little devices are about the size of a relatively large speck of dust. So I load those in and I squeeze them together, and I squeeze them together using, well, guess what, more diamonds. So I use the diamonds to squeeze stuff together because diamonds are super hard and also transparent. And that's really important for us because if it's transparent, we can literally watch what's happening. We can watch with microscopes like light, or we can watch with really big fancy X-ray machines called synchrotrons. So we can watch what happens to this little speck of dust that's been squished by the two diamonds and see when it starts to change its properties. And sometimes it's quite dramatic. Sometimes they change their properties and they go from black and you can't see through it to transparent or green or yellow or red. And you're like, oh, wow, what have we formed here? And sometimes it turns silver. So silicon looks kind of silvery anyway, but it's not a metal, right? It's a semiconductor. But if you squeeze it it actually turns into a metal.
Oh,
And when you do that, I know it's so cool. In the microscope, you see it go all silvery and metallic looking, and it looks a bit like mercury, and you can see it kind of ooze out a little bit, and it's turned into this metallic form of silicon. And then when we unload it, depending on how we release the pressure, we can get all these different exotic phases formed.
oh my God. Oh my God. I could talk to you for hours.